Alright, welcome back. So today we're going to be covering Boolean logic specifically for historical searches. Boolean logic is going to be incredibly important because you're strange, you're weird, you like weird things. It's history class and you signed up for it. And the fact of the matter is, if you wanted to look at the same things everybody else wanted to look at, you just, type your question verbatim into Google and hit I'm feeling lucky. But if you're a little weird, if you're really curious, if you want to find something very precise, and you know it's somewhere in that haystack, and you kind of know what needle you're looking for, then Boolean logic is going to be what brings us up. The other thing is that modern search engines, Google and Lycos, they have very complex algorithms. They have a lot of people who have put a lot of time into making these databases searchable. But if you get onto like JSTOR, if you get into like actual historical archives, you need to do a little bit of legwork yourself. So, no further ado, I'm just gonna click on it and keep going. All right. So today we're going to cover characters, character strings, Boolean operators, search operators, and ultimately creating a Boolean expression. It's a pretty short slide right here, but I figured that we'll get into it a little bit more. So first things first is a character. A character is any letter number that you can think of, and actually a space counts as well. So when you think about characters, you're thinking about data, really, because ultimately you're searching in a data-centric world. You're searching on a computer. Everything takes a little bit of coding, and really what you're doing is you're pulling out that code from a search. So you got 0 through 9, A through Z. You got the ampersand. Basically, every single thing that you would put in a text block is a character. And when you put those characters together, you guessed it, you get a character string. It's just a linear sequence of characters. That's going to be important when you're thinking about searching and how you're searching. Oh, hold on. Let me move myself down a little bit here. There's the whole string. Look at that. All right, so the reason this is important is because if you have different frames in a website and you search for something, it often won't pull those things together from different frames if you're looking at a string specifically. So you want to think of the data as being tied together in a nice linear pattern. So therefore, footstomp, a character string is a linear sequence of characters. All right, moving on to the basic Boolean operators. They're pretty simple, really. It's and, or, not. Some of you can also include the symbols, and I'll encourage you to use symbols when it comes to Google, because Google doesn't play nicely with the capital not, and then Google kind of follows its own rules on some of the other things. And truthfully, everybody does. So if you're getting into actual research, you want to find something out that is precise in that database, it's worth knowing what the search operators for that database are. So the key here is that these are logical expressions, which means that they're going to be akin to what would be like mathematical operations. So they help you refine your search to either include more things than you were getting before, or exclude some of the stuff that you didn't want. So we're going to keep moving on to the search operators here. And the search operators are basically everything that's command based. So all of the symbols, all of the terms that a search engine recognizes as being a command and not a character itself. So if you put an asterisk into a search, it will not look for an asterisk unless you put quotes around it or something. If you put same thing with a pound sign, same thing with a question mark. If you put something in quotes, it's not going to look for the quotes. If you put something in parentheses, it's not going to look for the parentheses. This is a command. that you are giving the search engine to say, this is how I want you to search, not what I want you to search for. So, foot stomp there. All the symbols that a search engine recognizes as not a character, but a command, is a search operator. So we're going to move on to the order of operations, which is incredibly frustrating, because your searches don't go from left to right the way that we typically would think. They go from top to bottom in an order of operations, with the wildcards being first, quotes, then parentheses, then not, and an or. Now this is true for every single search engine. This is typically true for like Google. This is true for LinkedIn. This is true for most major search engines. But basically what I'm saying here is, if I said Jacob asterisk, Boyce, it would, and I put that whole thing in quotes, it would still return, Jacob Peter Boyce and Jacob Stephen Boyce. It would pull in all the middle names, and also if I had two middle names, it would pull that in as well, even though it's within quotes, because the order of operations dictates that you do wildcards first, then they do the quotes, then they would put parentheses together, and then go through our basic order of our basic Boolean logic and Boolean operators. All right, so we're going to get around that because we're going to use parentheses more or less extensively for most of our searching. So here's what I want you to do. We're going to go into this, and based on what we know, of the the logic, and based on what we know of the operators, let's take a look. And it says write an expression, like a Boolean expression. Basically, make a search that gives you, that would actually give you King Charles the simple, but not King Charles the bold. So you can pause the video and think through it. Okay, good. You're back. Good. All right. So, getting to that, I need to kind of explain how a Boolean expression takes place, right? So we start off here with basically A, B, and C. So if I search for A, it's going to give me everything in A. If I search for B, it's going to give me this whole circle of B. And so we can see how these different terms, A, B, and C, are going to relate and interplay. So if I just say A and B, that will give me everything that's within A and everything that's within B. And that's going to be, that's going to be important. Because I don't want to hear of all of the King Charles. I don't want to hear of all of the simples, right? So A and B gives me what combines that, but you knew this. But basically the key here is a Boolean operator used to narrow the search is actually the word and. That gives you fewer search results. It narrows your search when you put and in there, which is kind of counterintuitive, but that's what it is. All right, and then we say A and B, not C. So this could be the not, or as we showed earlier, so it could also be the minus symbol, specifically in Google. But the word that excludes, especially after a term, so you have the first term and then exclude the second term. Now, the way to explain this is I put these in parentheses, and therefore this whole thing is seen as a term. So getting back to order of operations, going to the parentheses first, so to the not, this A and B is seen as a term, and C is another term. So it includes the first, but not the second. All right. Moving on. So here's what we end up with. I want King Charles. I want and I want the simple, and I want not the bold. Now I put everything in quotes here for the specific reasons I want that exact phrase. the default on Google would be just to search for King and Charles, and then it would say the and simple. But I want the exact phrase, and I don't care if these are close to each other necessarily. I just want them on the same page, or in the same document, and then not the bald, right? So that kind of gives me that like trifecta here of what I was actually looking for and excluding what I was not looking for. All right, so foot stomp there. If you put it in quotes, it's used to match the exact match for a search query, with the one caveat of, you guessed it, wildcards. All right, moving on here. If I say A or B, not C, I just want you to pause the video and predict what's going to get lit up. And welcome back. So A and B, not C, gives us this, right? We have everything for A or B, but we exclude C. So or actually expands your search drastically. It's like putting two searches in one, and it does not mean either or in terms of, if it has both A and B, or will still return that result. So it's a fun little game. We're going to take a look at the next slide, and this is where we get a little bit creative. So we have super. You notice nothing's in front of it. So what I'd like you to do is, once again, pause the video, look at all of these terms with the plus sign indicating and, the pipe, which is actually right there on the keyboard. It's above the right side enter key. If you hit shift and then the /, then it will give you a pipe, which stands for or, and then the minus sign, which says not. So all I want you to do is go through and try to predict what each of these will give you. All right, welcome back. So we got super and simple and search, and truthfully, this is what you would normally just put into, if you just Google search this, or if you put this on DuckDuckGo or something, this is what the default would be. Super and simple and search means that everything that it returned would have to have all three terms, super and simple and search. Number two here, if you have super but not simple and not search, that means you're going to return everything with super, but nothing with simple and nothing with search. There's a reason you do not put a minus super or search, because that kind of gets a little dicey on the logic, and that'll be kind of a guess and check game. All right, the next one in is super plus simple or search. So getting back to our three terms here, the parentheses goes first, and so this would return everything with super and simple, or super and search. So you have all of those options. The next bit here, we have super, not simple, and search. So once again, do what's inside the parentheses first. You have simple and search. So every document, every site with both the words simple and search are going to be excluded. So we're only going to be left with sites in documents with super in them, but without the simple and search. Next one is super or simple and search. So this kind of does the opposite of what the one before it, in the sense that it will give you sites or documents with simple and search in them, or it will give you documents with just super in them. The next one down is super or simple or search, and I hope you've pieced this together by now that this will give you all sites with either super or simple or search. So you're going to get a ton of results. This is the most expansive result. So when it comes down to it, you could say predictably the first one would give you the fewest results, and the last one would give you the most results, but that also depends on how big the internet is. All right, moving on. All right, so Google specific, because I know that you're kids and you like Google. So Google is kind of got some unique qualities to it that I altered our King Charles the Simple, and I added a little character in here that I'll talk about in a bit, about giving all of the dates between 800 and 1000, without the bald, without the England, without the fat. And here's also, first off, Google, I really like using the symbols. In fact, usually I like using the symbols, and even if the search query doesn't require me to put my Boolean logic in all caps, I still do it, because I want to know what is a search operator and what I am searching for. It helps me logically piece this whole thing together. So first off, Googlers out there, use the symbols. It's going to be easier in your head. Other thing is, look up specific symbols. Know what tools are available to you. This I don't know, partial ellipses. This will give you every single date in between 800 and 1000, and it'll also give you any number, integer, right? So you might get things that are not dates, but that's going to help things narrow down. Once again, the and symbol narrows down. All right, so then you got a space before. So if you're putting a search operator in, most search engines and most search queries are not going to recognize it as an operator if you don't have a space in before it. So unlike math, you have to have a character known as a space in there before it, and then no space afterwards. It has to be butted up directly against the next piece. That's a common mistake, and if your stuff's not working, it might have to do with what's known as a syntax error, which if you're old like me, you played on a Commodore 64 when you were growing up, you know and hate and fear the syntax error. All right, so wildcards. these are pretty site specific, but typically an asterisk gives you basically any number of characters to a limit. That limit is based on the basis of the character string. So if I said, RUSSI asterisk, it would give me Russia, it would give me Russians, it would give me Russias and Russianses and various misspellings or something. If I put a question mark before it, it could include Prussia, Prussians, and happy stuff like that. So the question mark before it returns a single instance of the character. So when you know a character exists but you really don't know what it is, you can put a question mark there, and it'll give you a single character. It's kind of dangerous because it doesn't usually recognize a space as a character. All right, so these are separating words by spaces. That actually takes a second little piece of code there, but so 19 question mark is going to give me a date that starts with 19, but also it'll give me like 19AB or 19XY, or basically 19 and two characters, right? 19 parentheses. So the next one is the hashtag or the pound symbol, and that one is going to return any integer. So if I wrote 19 hashtag, then that would give me a lot of the same results as what I have with question marks, but it would also give me 19,276. So it's any integer after that. All right, so if I said, this is the bloodiest asterisk in history, I get everything from the bloodiest battle, the bloodiest war, the bloodiest Disney movie, and if you go on to like page 400, it'll be like the bloodiest WWF, pre-cage match discussion. All right, I'm gonna get far away here. All right, so getting some gray area. Once again, this integer dot integer gives me everything between. So I glossed over this earlier because I knew I was I knew I was going to come back to it, but 1980 to 1990 is going to provide 1980, 1981, 82, blah, 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 blah. Super handy for historians, and super handy for anybody doing some precise research where they're like, I don't know, that car looked like a 67 Mercury, but maybe not. It's a good way of getting all those numbers in between as part of the search without having to call them out specifically. And then you have this around, gray area that says, well, I want the first term somewhere within the proximity of the second term. And in this one, the first one doesn't have to go first. So if I said, I want John around Doe, it would give me John Doe. It would give me John, it would give me Doe, comma, John. It would also give me John Jacob Jingleheimer Doe, and also Doe the John. So this is where you're trying to take these two strings and say, like, okay, I understand that there might be some, middle names here. There might be some, added material here. There might be somebody wrote it differently. I just want these two close enough together. So going back to our Charles the Simple, around would be a pretty good way of doing that. All right, so we're going to go into the, let's see, special search operators. So we need to kind of dive into this because you can have some terrible social studies teacher who's like, hey man, I want 10 sources and at least 2 of them have to be from an educational institution, and 1 of them has to be from a government institution. You're like, oh my god, do I have to really dig through the files that far? No, you don't. Here's what you do. You do your search like normal. Then you write the word cite, put a colon there, and then you write .gov or .edu. If you really want to go crazy into it, you can go to site pghschools.org. That will only give you sites that the domain PGH schools, because really what you're doing here is you're limiting down to a domain of a site. And it's a little complicated to think through the process, but basically your master level domain with just .org, .com, .edu, you kind of go from right to left in your site search. So if you want a specific site, you can put that in, or if you just want it to be like kind of large high level domain like .edu, you can put that in there. File type, also very handy, especially if you're basically trying to find like an academic something or something that was published. A lot of times those are in PDFs, or if you want to, if your terrible social studies teacher tells you to do a PowerPoint that's based on an educational institutions, you could just literally write file type PPT and it would return only PowerPoints based on the search criteria. And one thing I will call out specifically here is that if you put a dot PPT or a dot PDF, that's actually kind of like a search operator for a computer system. It doesn't really recognize it as a period, right? As the character period. And so for file type, even though you might want to put dot doc, just put doc, just put PDF, just put PPT or PPTX, and that will return your stuff. And truthfully, it's not about getting it right the first time. It's about troubleshooting it until you get it right. And then sooner or later, you realize you troubleshoot less and less than you used to. So the cache one, this is used to return a stored version. So Google and the Wayback Machine and all these things will actually give you a stored version of this site, because either maybe the site that you wanted was taken down, it's no longer being hosted on the same server, or maybe you just don't want your cookies to be from that site to be downloaded on your computer, or you don't want the people from that server to know that your IP address was visiting their server. I mean, whatever your intentions, I understand. I'm just saying that using cache gives you a version of that, oftentimes an older version, based on on a different server. And so, if I go to Ancient EDU, Charles the Simple, this is not going to be hosted on ancient.eu. This will be hosted on a Google search server. And truthfully, the way that search engines work is they literally copy and scrape data from every single website, which is why you can search for things so fast. But if you try to search for a file on your computer, it seems like it takes forever. And then the at symbol or the at mention, this just searches social media, but at Mr. Boyce, you already knew this. All right. So moving on to the next step here, we got search operators and Boolean expressions. We kind of covered this. A search operator and Boolean search operators are all the terms and symbols that search engine recognizes as a command and not a character. And a Boolean expression is a logical combination of predetermined Boolean operators. So you can see that I put my King Charles around the simple, and I put my date range, and I said not the bald, not or of England, or the fat, and I just want PDF files that are educationally hosted. So that's going to give me some incredibly specific. And you know what? If that needle's out there in that haystack, it's a whole lot easier to just ask for it than to go dig through the haystack, right? And then the Boolean expression is the logical way in which we put these things together. All right, so question for discussion is right here. Why is it more important in historical and archival research? And with that, I look forward to hearing your thoughts. All right.